took it.
All right, hello, good morning. It is Friday, November 1st, and I am Rob, that developer dad, and we've been designing a admin portal that I'm going to use to help me automate some of the boring business stuff that I'm going to have to do while running the DM's Familiar. So yesterday I got to a point where I think we can start talking about building out a vertical slice. It may not be fully functional, but we can at least start grinding out the component interaction patterns that we want to use, and get some of the project structures in place now. So without further ado, I'm going to bounce over to my screen share. And let's clone a repository. And I have to go get that repository address. So let's grab this. I'll go back to code. And I've only got the one branch. So let's copy this. Shrink here. Paste here. And let's go back to projects and that dev dad. Select folder. I have to create an empty folder. Okay, so hang on. Do this and create a new folder called DM Familiar Admin. We're going to select this one. Here we go. And yeah, that's what I want to do. Browse this. And let's grab this one. Clone that. And here we go. So we've got just the docs folder right now. I'm going to need to add a new folder called source. This folder hasn't got anything in it, so I'm going to need to add, well, file, new, project. And I want a empty solution. Here we go. We'll hit next. Solution. Nope. It's going to go in. C:, projects, in here, here, and this totally put it in the wrong damn place. Why? Why even would you do that? Gah. That's really dumb. source. We're going to select this folder, and it is going to be devdad SaaS admin create new solution. Yep. Create. And I want to see the file view again. Well, no, I want to open in File Explorer, make sure everything's set up correctly. So here's this. We're going to go into the source folder. And I'm actually going to pull the solution. That solution file is going to go into the root of the source folder. Delete. And new folder. Clients. Managers. Engines. Resource access. Tests. And IFX. All right. Now, can I add all of these? I guess I'll add them as clients. Managers. Engines. Resource access. Oh, I spelled that wrong. Rename. Resource access. Tests. IFX. How did I spell that? Folder could not be completed. The parameter. Don't bite me. Open folder and file explorer. Why are you being a goose? It's being a goose. Quick access. How about documents? Nope. Percent. User percent. Oh, for crying out loud. Users may and where are we? Source. Come in here. Source file. Okay, I did that with a capital X. I've got clients, engines. I gotta fix the case on the solution folder, managers, resource access, and tests. Good. And I gotta rename this guy. course, it doesn't let me rename that. Can I edit it? You gonna let me edit it? Ugh. I have to close this. This is so silly. Save. Save. All right. Save. Yes. There we go. Now I need to go into this folder. Nope, not that folder. But, oh gosh, where did it get stuck? So lame. This is so dumb. I don't understand why it didn't respect my choices. Need to open with Notepad. And instead of IFX with a little x, it's IFX with a big X. There we go. Save. And we can reopen Visual Studio. Yes, I do. And open a project or solution. Come in here. And pop in here. Excuse me. All right, the first thing we should add. And I want this. Go to Docs. And do I have components fleshed out here? Managers, engines, resource access. Cool. So let's take a look at the account manager. So down here in our managers class, we're going to add a new project. And since we're just coding, and we're coding like back-end type stuff, once again, we're going to be returning to the world of oops, all class libraries. So next, class library is going to go into the managers folder, and it is going to be called devdad.sas admin.account manager. We're going to use .NET 8, and it is creating. We're going to rename this to account manager. Nope. And of course, it didn't take the capital. Account manager. This becomes public interface. Account manager. I hope my keyboard hasn't given up the ghost. That'll be a massive pain in the neck. Here we go. So we've got iAccount Manager. And let's take a look under here. And I'd specified TD SaaS admin as the root namespace, but it's devdad.saasadmin. So I should pop over here and under nerd stuff, it becomes devdad.saasadmin account manager. Whoops. Commit changes. I have to edit it again because I missed a T. Gah. Here's that. And let's commit those changes. Still not 100% in love with that naming. Let me think. It'll be fine. Now, we're also going to need to add classes for first thing I need to do is add a new folder, and I'm going to call it contracts. And iAccount Manager is going into contracts. Yes, I do want to adjust the namespace. Lovely. We are going to need add a class. It's going to be called customer profile. And it's going to be public. I have to remember that the Apple keyboard command corresponds to window and not control. You're also going to need a class for profile request. It too will be public. Save that. And we're just going to leave these empty for now. And add a class. It's going to be called subscription action request and will be public. and another class called customer subscription. And I believe we now have all of the things that we'll need to be able to construct our interface. This needs to be public. So there's our customer subscription, subscription action request, account manager, excuse me. I'm just going to go ahead and leave customer profile request all on its own. Yeah. All right, so this is going to return a customer profile or a nullable exception. Load or create customer profile. Customer profile request. Request data. Now, we've got some anger code here. Oh, duh. I forgot the comma. Here we go. And then, man, that's the one downside to working in full-on Visual Studio is, at least running on a Mac like this, is I am continually, like when I flip back and forth, the muscle memory from using the Mac keyboard shortcuts overrides my muscle memory for working on a Windows keyboard, and it's really annoying. Customer profile. Exception. And it's going to be store customer profile. That's going to take in a hydrated customer profile. There we go. And then finally we've got customer subscription, exception, manage customer subscription, and it is going to be of customer subscription action or subscription action request. Action request. Save. Don't stop it. Jinkies. All right, so we've got that. We're also going to need a customer builder. Now that's going to be an internal class. And we're going to add a class right now to the root, and it's going to be called a customer account manager. Jinkies. I keep hitting the wrong bloody buttons on my keyboard, and it's driving me bonkers. Account manager. Implement the interface. And I have to rename the file. Yes, do that too. And you'll see here that it's internal. Holy crap. Rename account manager. What is wrong with me this morning? I really just... I've got a horrible case of morning onset craniorectal impaction. And that's just like big fancy words for I've got my head stuffed up my butt. I'm also going to add a class called Customer Profile Builder. And hit add on that guy. And these are both going to be internal. Now, just because I'm feeling really, really crazy. Well, not really, really crazy, just curious and silly. I'm going to be a silly little guy, and I'm going to leave both of these internal. And I am going to commit a small amount of, well, yeah, it's going to be heresy. Because modern .NET, we want to use dependency injection and all that stuff, right? But I don't like the way dependency injection forces me to make the root class of whatever is sort of acting as the program of my executable have knowledge of every dependency of every dependency. Because I don't want people to inject my customer account manager into some other manager that has nothing to do with customer accounts just because that account manager has a method that looks like it might do what they need it to do, and then they discover that it doesn't, so they go into the account manager and change that method so that it does what they need it to do, and suddenly the whole system blows apart. It really, really breaks encapsulation and the closed architecture that I'm trying to build here. So instead of exposing Customer Account Manager with its public constructor and all of its stuff, all of its dependencies, we're going to try an experiment. And in here, I am going to add a new class, and this guy is going to be public, but it's going to be called Service Factory. This guy's going to be public. And it's going to have one, maybe two methods on it, but public account manager create proxy. It's going to be create proxy. No, I'm going to say create service proxy. And we're going to need to add a new project to IFX. It's going to be a class library. Next. It's going to be devdad dot SaaS admin dot ifx, and it's not going to go in the root of the source folder. It is going to go into the ifx folder. There we go, and we're going to create it. It's going to be .NET 8. Rename this default class that got added to iService proxy. Yes. It's going to become an interface. Save. Dang, blast it, doofus. Now, Service Factory over here in over here in the Account Manager assembly, this concept is going to come over to iService Proxy, or rather iService Factory. We're also going to need an iService Factory over here. So we're going to add an interface called iService Factory. Add. It too shall be public. And it will describe T What's this class do? Okay. It's going to have a service proxy of T, create proxy, save this, iService proxy of T will also inherit T. And this is going to get crazy. Cannot derive from T because it is a type parameter. Okay, that's fine. Now, where can I do where T is an interface? It won't let me do that. So, over in the rules utility, late last week or early this week, I created basically a marker interface. So what I'm going to do is I'm going to add a new folder called System Model. Add new item, interface, iService. All right, it's not going to have anything on it. Me and my stupid muscle memory. And we're just playing around with some code here. I'm doing some crazy stuff. Stuff that I have seen elsewhere before. I've heard other architects and luminaries in the field of software architecture describe. And I've never fully grokked because I've never actually built out this concept from scratch. And I really want to. iManager service. There we go. This also will be public. And what this is going to do is it's going to let us use type constraints on some of the generic things that we're about to be creating. And these essentially just are going to help us enforce this closed architecture that I want to build. So we need to add a couple more. Class, not a class, but a new item. It's going to be an interface. It's going to be engine service public file save all. I'm getting a lot of stuff cracking open here. Add another interface. I've been seeing a lot of arguments on LinkedIn lately of people disparaging folks that always code to interfaces and so on and so forth and all of that stuff. And I think it's just because they come from language areas that don't have them or have anything like type safety. Or work with things like generics a lot. Of course, if you're going to have generics, you have to have type safety. Excuse me. Because generics are really just a shortcut or sort of a signal to the compiler that says, hey, when you see this class of type T, you're going to need to look for all of the type T's in the system that are used, that implement this method or are used by this method or what have you, and actually compile the strongly typed versions of these methods for me when you run. Now, we've got resource access service, manager service, engine service, and we are also going to need now, I'm not going to wrap utilities in this concept. However, what I am going to do client service. Public. Save. What are these things? A service within the system. Key bindings. This is almost this is becoming comedic. This is like me doing those Jack Tripper falls where I like just do the dead man fall behind a couch or whatever. Identifies a service within the system that acts as a client to the system. Acts as a public client to the system. In a solution that does not include a user interface client, there must at least be some kind of API client that provides public face of this system. devdad saasadmin.ifx. And as a matter of fact, these are likely to get promoted out of saasadmin.ifx into a that developerdad.ifx component once I've got them ground out right. Because I might discard this concept. Public interface at client service inherits from I service. Identifies the component that includes this interface as being a member of the manager service archetype. And as I'm creating these entities and documenting them, I'm remembering that there's actually a code base that implements this idea, but it's against an older version of .NET. In fact, it's a pre-.NET Core, and it's heavily reliant on WCF for a lot of its intricacies and a lot of the internal behavior. And unfortunately, .NET Core doesn't include those parts of the old .NET Framework runtime. So I'm going to need to basically re-implement those concepts as best I can. And I'm not talking about the inner concepts that rely on, the old technology that we don't have available to us in .NET Core. And it's fine. The reason we don't have WCF in .NET Core is because it has tight dependencies on older, like 1990s, early 2000s era Windows components. And we don't have those components in other operating systems. So obviously they couldn't include those in .NET Core, because the goal of .NET Core is to have it run on a Mac, have it running in Linux, having it run basically anywhere. And I like that. So I'm going to use it because it means I can use a Linux-based host instead of a Windows-based host. And that means I save a lot of that. So the engine service identifies a component within the system as a member of the engine service archetype. And I remember back before I took this architectures class, or this architects class, years and years and years ago, I was starting to see these patterns that there are, like even within my own service-oriented development before I got this education that I received, that various services could be built to conform to specific archetypes. And I was like doing a lot of mental work and a lot of thought while writing my code for, whoever I was employed by at the time, about like this taxonomy that could be applied to the different types of assemblies that we compose together to build our software systems. And then I found this course and I went, hey boss, you have to send me to this. And my boss was awesome. And he looked over the course and he was like, hell yeah, let me find the money. So he went to his boss, and I think he had to go to his boss's boss and secured the bag, paid for the course, paid for my flight to the other side of the continent, said, get yourself a room, rent your car, blah, 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 we'll expense it all. You're going to this course. So me being me, I found the cheapest hotel that I could find in San Jose that was close to the Microsoft campus where this course was being held. I went to like McDonald's almost every night, like McDonald's or a cheap pizza by the slice or what have you. At the Microsoft campus, they've got a fantastic cafeteria, by the way, and Microsoft makes their cafeteria prices dirt frickin' cheap. It's lovely. I'm very jealous of Microsoft employees. And so I got the cheapest hotel. I think it was less than $100 a night in San Jose, which tells you what kind of hotel it was. I didn't even rent a car. I just took Lyft to and from the campus because it was like $10 a round trip, like 5 there in the morning and 5 back in the evening. There was plenty of cheap places to eat within walking distance of the hotel. I did it super, super cheap. But that's besides the point. I went to this course, and that archetype concept, that taxonomy of system component thing that I'd been reaching for and thinking about and trying to grind out and describe, they dropped it in my frickin' lap. They were like, over the course of that week, they were like, yeah, here's, the components in our system could be broken down to a small handful of types that fit into this hierarchy of client, manager, engine, resource access, and utility. And that's it. And I was like, oh my God. and this was pre.NET Core. So they were building everything off of WCF and describing everything in terms of WCF, Windows Communication Framework. And it was great. Loved it. Changed my brain. So here I am trying to implement that framework that they introduced and shared with us in .NET Core without WCF. And it's going to be tricky. Now, these interfaces, like I said, they're going to be marker interfaces. All they do is put the eventual interfaces or the eventual component contracts and the materialized components into families. Like they formally place them within the taxonomy. And if I can get it to work, I am going to be adding a little tiny bit of low-level behavior into these different components. Because now with .NET 8, we can actually add methods to interfaces and provide a default implementation for those methods. All right, so a resource access service. Let's just take a gander at iEngine service. And where's my manager service? Okay, that's inheriting. It's described. Let's close it to clear up some of the noise on my document bar. Resource access I'm still working on. Engine I'm still working on. Let's grab manager service. It also needs to inherit from iService. Save. iEngine service needs to save. Identifies a component with this marker interface as a formal system service with a place within the system model. I think I do need to define a utility because there are rules for utility. Or rather, utilities break some of the rules. Sort of. iEngine service, iResource access service inherits from iService. Now this iService thing could almost become conceptually redundant, because the philosophy that was plugged into my brain is that every class is a service, or we should think of every class as being a service, and interact and have our classes interact with each other the same way our more macro-scoped services interact with each other. So it's a bit of a weird head twist to get through. So summary, resource access services encapsulate the details technical details and volatilities inherent with storing and retrieving instances of our systems objects, subject instances, and let's check my spelling. Technical details and volatilities inherent with storing and retrieving instances of our system's subject instances. A resource resources are not limited to this conceptual subject. System subject. However, and may, the idea of a resource, the concept of resources is not limited to these system subjects, however, and may also refer to capabilities or information provided by remote systems that are not directly connected to the current system scope. I like that. I like that a lot. Therefore, a resource could be a user account stored in some identity store, a user account some identity store, trusted identity store, Microsoft, Google, Apple, Meta, etc. A record in our systems, relational or no SQL database, a file or other data object stored in a storage service, cloud or otherwise, a remote API that can perform parts of our workflows for us. Remote IoT devices, or even an LLM. Even an AI such as a large language model or other machine learning service. Because of this wide variety of resource kinds, along with the need to adapt quickly to changes in other systems, APIs, we need to encapsulate the complexity and volatility of accessing these resources into a simple, into a stable interface for the rest of our system to consume. And that, I feel like, is a pretty good layman's definition of resource access. Now, normally I wouldn't write that gigantic novel for a summary for a summary comment, because that's bananas. But I really wanted to flesh it out because this, in addition to this code base creating my admin system, I'm also doing this for educational purposes. I'm doing this to share the hows and the whys and the whats of what I do when I make software happen. And I feel like being extra super explicit in some of my comments in my code base, it feels like the right thing to do. Even though, you know, my gut's telling me, dude, you need to just put this into articles and essays and stuff, and I ain't got time for that. I just want to write code. So identifies a component within the system as a member of the engine service archetype. And engine service is a doer within the system. There's a component that does stuff. does stuff. Calculations, transformations, decision making based on input data, etc. Probably one of the more ubiquitous kinds of engine component is a validation engine. If you're spelling in the habit of pulling that code into its own class or library within your systems. Probably the most ubiquitous kind. And there's discussion in the architecture groups that I'm a part of that validation might actually have a better place in under the utility concept. But there's a lot of friendly disagreement within the group members and the folks that run the group about that. I'm gonna leave validation as under the engine concept, and let's load up manager. Manager services. Use engines and resource access. Engine and resource access services to perform specific use cases. Like an orchestrator or conductor or of sorts. Methods exposed by manager services must be considered the exclusive entry point to the capabilities defined by the engine and resource services. Those service kinds must never be called directly from outside the system. members of this archetype may call engines and resource accessors. Members of this archetype may not directly call other manager services. I need to come into engine service. Engine services are only called by manager services. Engine services may call into resource access services. Engine services may not call into other engine services. Engines may not call manager services. Where's my client service? I should add a note. Client services are the ultimate top of a system architecture and may only call down into manager services. Excuse me. Manager service, we've got my rules. And I'm going to say, instead of members of this archetype, I'm going to say managers may call engines and resource accessors. Managers may not directly call other manager services. Here's engines. And finally, let's put the rules for resource access. Resource accessors may not call up the stack. Accessors may be called by either managers or engines. Resource accessors may not call across to other resource accessors. All right, and I dig that. There's one more canonical system type. And it is an utility service. Public utility service. And as a matter of fact, there's very few rules about the utility service. And they're more conceptual. And the way I think about utilities is I tend to think of them as directly injectable, pre-configured instances of a service, such as a message bus publisher, a message bus listener, a logging utility, a rules execution utility, or a rule execution utility, stuff like that. I do not believe there's a need for that abstraction. So I'm going to delete it. I'd been thinking about it, but just talking through the concept of what a utility service actually is got me to where I could reject needing to create that as a thing, as an actual material service contract or contract marker. So we've got our service archetypes documented out. I dig it. Engine service. All right. Service. Formal system service with a place.
Bye.
Okay. Have fun storming the castle. It's not supposed to be raining down where you guys are going to be.
Yeah, I know. Did you bring umbrellas?
Formal system service.
One of the cars.
Identifies a component with this marker interface as a formal system service. Within the system model taxonomy. There. So save. Our iService proxy. It's a service proxy of type T, where T implements iService. I think I need service proxy to not be an interface, but rather maybe a base class. Now that I've got this constraint on here, can I have it implement T? Nah, it still won't let me do that. But can I do this? Public abstract class service proxy of T implements T where it's still not going to let me do that. Wait. No. I'm not gonna go any further on this concept yet. I'm gonna go pull down and review that iDesign service, extended service model code around this proxy pattern between now and this afternoon. And I want to see if there's a way I can kind of make it go. Because I used to do a thing with WCF service proxies where anytime some component needed to make a WCF call to another component that was outside, I had a really, really nice pattern that would both have the proxy kind of act as the shim around making the WCF call and also expose whatever the component's interface was, so I could talk to the proxy as if I was talking to the actual service. And that's kind of what I want to do here. And then once I've got my service proxy figured out, I'll be able to do the service factory or the proxy factory, where I would be able to inject a concrete instance or implement a concrete instance of this iService factory concept where I create the service proxy for the manager or the service that we're implementing within account manager, and B, build its dependencies in whichever way need to be built based on the configuration information. So instead of building out all of my account manager's dependencies in program CS in whatever root program runner, be it a console app or an ASP.NET API or web app or what have you, I'll be able to just grab a proxy to the outermost actual functionality providing services. My main application that's creating the API would only need references to the managers. And then when it calls the service factory on each of those managers, that service factory would then be responsible for spinning up all of that manager's dependencies. And we're still going to be working against interfaces and such in here. We're still going to be coding to interfaces. But the actual concrete instances of those dependencies are going to be instantiated by the component's local service factory, rather than some component that shouldn't have any knowledge of the inner workings of the components it's creating. So this is kind of plugging that leaky abstraction problem that I personally have with current .NET dependency injection. I mean, what they've given us is fantastic, but I would prefer to have something that's a little more strict, a little more keep the cards to its chest than what I typically see in a lot of .NET Core applications, where program CS is just like 6 miles long of of dependency instantiations, and everything's got access to everything that can talk to that iService collection or the iService provider, and that feels really, really dangerous for the sanctity of my systems architectures. So I want to take a swing at building it this way, and if I can't get it in a reasonable amount of time, like if it looks like it's going to take me days and days and days to get these concepts ported into this .NET Core app, I'm going to abandon it and just do it the way everybody else does it, and just be super strict on myself about not breaking my logical architecture. But if I can pull it off, oh, you bet your butt that this is going to be the framework that I have to build for this is going to be extracted from this solution and set up as a component. under like my components dash set of repositories up on GitHub. So cool. Well, this has gone a little longer than I intended to today, and I started off with my head all fuzzy, and then I got into this, and I got excited and carried away and info dumped and all kinds of stuff, and that's fine. I hope you don't mind, but I got to take a little break. I'll be back at 1 p.m. and we'll keep going with this. I'm going to try to do a little bit of homework between now and 1. So that I've got a clearer view of what all this stuff looks like, because I'm going purely off memory. But I need to see how they did it mechanically in .NET to be able to really dig in and see what's what there. So, and I really need some more coffee. So thanks for joining me, and I will see you at the next video. Take care, folks.